We have given here one simply supported beam and we have support at A and C. At point B, which is 0.25 L from A and 0.75 from B, a concentrated couple M0 is acting. We have to find out here strain energy U, and the product of E into I is a constant value. So total strain energy U is consist of two parts. First you have to calculate the strain energy in AB, and then you have to calculate the strain energy in BC part. And we have strain energy U is same as equal to integral mx square dx, and is divided by 2 times the product of EI. So to find out the value of mx here, first you have to find out what is the reaction at A and the reaction at C. So we'll take the sum of moment of all forces above C, and we have clockwise moment is positive value, that must equal to 0. Moment of AY above point C will be clockwise, so we have AY, and we have perpendicular distance is L. 0.25 plus 0.575 is L, plus we have M0. M0 is a clockwise, is taken as positive value, so must equal to 0. So we are getting this time the value of AY equal to minus of M0 divided by L. This answer is negative. It means that the value of AY will be equal to M0 divided by L. We have assumed it upward, so it will be acting downward. So this one correction you have to show first. Secondly, we have sum of moment of all forces about A must equal to 0, and we'll take the clockwise moment positive. At C, we have vertical reaction equal to Cy. So Cy above will make anti-clockwise moment is minus Cy. Perpendicular distance is equal to L, and this time the value of M0 is positive. So we have plus M0 must equal to 0. So in this case we will get the value of Cy is equal to positive value of M0 divided by L. This answer is positive, so assumed direction is correct. So you have to correct this figure here, and then you have to take the section between A and B and C. So this time we have AY will be equal to M0 divided by L and is acting downward. And at C we have M0 divided by L is acting upward. So we'll use this figure, and now we can calculate the strain energy for AB and then for BC. To find out the strain energy for the beam AB, I will take the section just on the left hand side of B. So let's consider this section here at a distance equal to x from A. At point A, we have one force is acting in a vertically downward direction is equal to M0 divided by L. The section at distance equal to x. For this segment AB, x has a limit, lower limit will be 0, less than equal to x, less than equal to 0.25 times of L. One shear force will show in a downward direction that equal to Vx, and one internal reaction will show here that will be M1x. This value of M1x will be same as equal to the force. To find out the value of M1x, we'll take the sum of moment must equal to 0, and we'll take here anti-clockwise positive. So we have M1x is a positive value, and moment of M0L above the given section plane is anti-clockwise, that is also positive value, is M0 multiplied by x divided by L must equal to 0. In this case we have M1x will be equal to minus of M0 multiplied by x and is divided by L. This one is M1x. So strain energy in the portion AB will be given as integral. We have limit is from 0 to 0.25 times of L. We have mx square will be same as equal to M0 square of it multiplied by x square divided by L square, and is further divided by 2 times of EI, and is integrated with respect to dx. So that will be equal to M0 is a constant term, can be taken outside. We have 2 times of E into I multiplied by L square. Integral of x square is x cube by 3, that is we have 0.25 times L, and we have cube of it divided by 3. So we will get here m0 square into L cube is divided by 2 into 3 is 6 times E into I into L square, and this is 1 by 4. 1 by 4 cube is 1 by 64. That is, we have strain energy in the AB portion will be equal to m0 square of it. 1 L is left. In denominator we have 6 into 64 is 384 multiplied by E multiplied by I. So we know the first value here, that will be equal to m0 square into L and divided by 384 times of EI. Now we'll proceed for BC. Now we'll consider here for BC portion. So BC portion, we'll take here the section which changes from B to C, and this distance from C will make it equal to x. In this case the limit of x is 0 less than equal to x less than equal to 0.75 L, that is 3 by 4 L, or we write here 0.75 times of L. So at point C we'll show here one force which is acting vertically upward is m0 divided by L, and our distance here will be equal to x. This moment above the section plane is anticlockwise, so we'll take this moment as an internal moment will be equal to m2x, and one shear force will show in a vertically downward direction, that is v2x. So sum of moment equal to 0. This time we'll take the clockwise moment as a positive value. So m2x is a positive value, is same as equal to m0 multiplied by x divided by L, and our limit is from 0 to 0.75 L. Already we have solved for AB. Now we are solving for B to C. So we have strain energy for BC is equal to integral from 0 to 0.75, that is 3 by 4 L, is mx square. Mx square is same as m0 square into x square divided by L square, further divided by 2 times of EI, and is multiplied by dx. So we can take out here m0 square common. Even we have 2 times of EI is common, L square is common. Integral of x square will be x cube by 3. Now this time we have x is equal to 3 by 4. So we have 3 by 4 is 0.75. We have to make a cube of it into L cube. Lower limit is meaningless. And we have x cube by 3. So you have to divide it by 3 here. So we'll get this value as m0 square. We have L cube divided by EI into L square. 1 by 2 is left here. We have 3 cube is 27 divided by 2. 4 cube is 64 is divided by 3. 2 into 64 into 3 is same as 384. So we have 27 divided by 384 times m0 square into L divided by EI. And now already we know the value of U AB. So total strain energy is same as the strain energy in AB is m0 square L divided by 384 EI, plus we have 27 divided by 384 times m0 square into L divided by EI. So here we have 384 is common. We have 1 plus 27, that is we have 28 divided by 384. If we divide numerator and denominator both by 4, in numerator we'll get 7, in denominator we'll get 96. So final answer is 7 divided by 96 into m0 square into L divided by EI.